Okay, so we're going to talk today about hyperbolas. And so a little bit up there it says, when an airplane travels faster than the speed of sound, the sound waves form a cone behind the airplane. If the airplane is flying parallel to the ground, the sound waves intersect the ground in a hyperbola with the airplane directly above its center. A sonic boom is then heard along the parabola, or along the hyperbola. Okay, if you look next to this next one, it says long-distance radio navigation for aircraft and ships uses synchronized pulses transmitted by widely separated transmitting stations. The pulses travel at the speed of light. The difference in the times of arrival of these pulses at an aircraft or ship is constant on a hyperbola, having the transmitting stations as the foci. Okay, so basically what I've done is I've given two examples of where hyperbolas are used, because a lot of people, they don't know whenever they're going to be used. Okay, and they see this figure and they're like, well, when would anything like that ever happen? When would this ever happen? This is an inverted hyperbolic paraboloid. It's at the Pengrowth Saddle Dome. Okay, the level curves of the surface are hyperbolas. So you can kind of see a picture right there. So anyway.
That looks like really inconvenient. Like the people sitting up in the top right part wouldn't even be able to see anything.
And if it rained, it would all like go in the middle.
I think they've got it structured to where the rain kind of would run off. So anyway, you should have written these down. This is the standard form of a hyperbola. Now we're going to individually look at these. Now first of all, if you notice one thing, a difference between this and ellipses is this, the subtraction side. Big difference. Okay, you now subtract with the hyperbola. Another difference is that whatever term is first, if x is first or y is first, that tells you where it's going to open. So this one first is x squared, that's going to open along the x. Y squared is first here. Actually, it's which one is positive. But the y squared is first here, it's positive, so that means it has a vertical transverse axis. The other thing, A is always first, B is always second. So A always goes with the positive, B always goes with the second one, with the negative. Okay, so A is not the largest here as it was with an ellipse. B is not the smallest. You can actually have those switched around. Another thing, C squared equals A squared plus B squared. That's a little different because if you remember in an ellipse, it was C squared equals A squared minus B squared. And finally, we have what are known as asymptotes. And asymptotes basically give us guidelines as to how the hyperbola is going to open. Is it going to open narrow, skinny? So this is what's going to happen. You're going to end up having an asymptote here. Actually, two of them. That's where the plus or minus comes in the formula. And what that's going to do is that's going to give you guidelines for how the hyperbola is going to open. So that's why you need the asymptotes. Notice there is a difference between the two. All right, any questions?
No.
Okay, so let's go ahead and look at this. It says name the center, foci, vertices, and the equation of the asymptotes then graph. So we're going to start with this one. Now, these are a little bit more labor intensive than the ellipses were. Yeah, they are a little bit more labor intensive.
It's kind of like harvesting cotton in the south, or you go up north and you're working in a type area.
So first of all, what direction is it going to open? Up and down or left and right?
Up and down.
Up and down because y is first. Yep. Y is first, it's positive, it's going to open up and down. Next, what's the center going to be? 0, 0, because there's nothing done to the y's, there's nothing done to the x's. So once again, in order to identify the center, I'm just going to use a little star, because remember, the center is actually not a point on the graph. Now what I need to do is I need to find A and B. What's A? 3. What's B? 5. So what that A implies is that I'm going to go 3 up, just like I did with an ellipse, and 3 down. Okay, so these are what I call my vertices. So my vertices here will be located at 0 plus or minus 3. So I could write it as 0, 3, and then 0, negative 3. I don't need to put the plus or minus, or I could abbreviate things that way. Okay, the foci, I need to find the foci. So to find the foci, I need to find what C is. Okay, so to find what C is, I know that C squared equals A squared plus B squared. So I get, yep, 9 plus 25. And so C squared equals 34. So C equals root 34. Just for kicks, what two integers will root 34 be between?
5 and 6.
5 and 6. Okay, so it's probably going to be closer to 6 because 34 is closer to 36. So what that means is that my foci are going to be located about right here, okay, and about right here. Now, once again, the foci aren't going to touch any part of the graph. All they're going to be is there like they were with the parabola. And my last and final thing is I need to find the equation for the asymptotes. So since this opens up and down, does anybody remember or have written down what the equation will be?
Y minus K equals
Plus or minus?
A over B.
Yep. A over B.
Quantity X minus H.
X minus H. Now, we already know that H and K are 0, right? So pretty much those are gone. So those are gone. And then I know that A is 3 and B is 5. So really my equation for my asymptotes are plus or minus 3/5 X. Now this is what we're going to do. We're going to start at the origin. And I'm going to plot a slope of 3/5. What's the slope of 3/5? Up 3 and then over 5. All right, now I don't have any more room to go, so I'm going to go down 3 to the back 5 and there. Okay, so there's your first asymptote. Okay, your asymptote. Now for the negative one, you're just going to do the exact same thing except for you're going to do the opposite. So down 3 over 5 and then up 3 over 5. So you're going to end up finding that all those dots are going to kind of make a rectangle. And then you're just going to go ahead and draw in. Now once again, if you remember what I said, that's a guideline. So obviously you can see this hyperbola is kind of wide. And all I need to do now is just draw the points that connect it. So a little bit about the hyperbola. It is not cupped. I mean, this should be solid. It shouldn't look like this. Okay? Some will do that. They'll do it. Trust me. And that's why it's straight. It doesn't go up any. So like right here. There you go. So anyway, make sure that that's what it's going to look like. All right? So that's a hyperbola. Questions? All right, let's look at another one. Okay, x squared over 25 minus y squared over 16 equals 1. X squared over 25 minus y squared over 16 equals 1.
Left and right.
Okay, yep. First of all, it's going to open left and right because the x is positive. What's my center going to be?
0,
0, 0. Okay, so X, well, a star marks the spot. What's A? 5, B is 4. So my vertices. Okay, where am I going to go from the center? Five over and 5 here. Okay. So your vertices, what would the coordinates of those be? What would they be? Plus or minus 5, 0. Good. Alrighty, next thing, let's find the foci. So to find the foci, I know that c squared equals a squared plus b squared. So a squared is 25, b squared is 16. So c squared equals 41. So C equals root 41. What's root 41 approximately? 6 point. Between 6 and 7? So there's where your foci are. Okay. And then now we have to find the equation of the asymptotes. Okay, so to find the equation of the asymptotes, what's my equation if it goes left and right? Yep, there you go. So once again, since I have a center at 0, 0, those are gone. So I end up having y equals plus or minus 4/5 x. Okay, so from the center, 1, 2, 3, 4, 1, 2, 3, 4, 5. Another way you can do this, if you notice what I'm doing, I'm making a rectangle. Do you see how that is done? Okay, so since I went up 4 over 5, I'm going to go then down 4 over here. I'm going to go to the left 5 and then up. So I've really made a rectangle. This is pretty much how your asymptotes will always fall into place. Okay. So that's another way that you could draw in the asymptotes. If that first way we looked at makes a little better sense, great, stick with that. And then all I'm going to do now is go ahead and draw in my hyperbola. I have a little bit more room on the left side, so that looks a little bit better than the one on the right. But there you go. Questions? All right, we're going to look at, I believe, one more today. Okay, I believe we're going to look at one more today. And we'll continue with this on tomorrow, on Friday. Okay. Now this one is different because if you notice with this one, the center is not at 0, 0. So first of all, which way is this going to open? Up and down.
Because the x is positive?
No, because the y is first.
Yep, the y is
the
first.
y is first.
Yep, it's whatever one is first with the hyperbola. Okay, so what will the center be located at? Negative 2, 4. Good job. Negative 2, 4 because it's always the opposite of x and then whatever the opposite of y is. So my center is going to be at negative 2, 4. So there you go. Now I need to find my vertices. A is 4, B is 3. So to find my vertices, I'm going to do what from the center here? Yep, and down 4. Okay, so what will the coordinates of that be? Negative 2, 0 will be 1, right? What's the other one going to be? Yep, negative 2, 8. Yep, good. That's why it kind of helps to do the graph as you're writing these down, because then you can see what they're going to be located at. So to find the foci, c squared equals 16 plus 9. So what does c squared equal? 25. So what does c equal? 5. So from the center, I'm going to go up 5 and down 5. So notice here the foci are actually a little bit closer. What's the final thing I need to do? Asymptotes. So asymptotes, what was the equation? I've got the y minus k. Is it b over a or a over b? A over b. And this one is x minus h. Now, this equation is going to look really confusing when we have all the numbers in, and I'm going to show you a real quick way to know what to do after. So, y minus k is y minus 4. If you get confused as to what to write, just look up here at what's in the parentheses. Okay, I mean, that's the easy way. Equals plus or minus, what's a over b? Okay, 4 over 3. And then once again, to find the parentheses, and you just plug in x plus 2. There's your equation. That's the answer. Okay, that's the equation for the asymptote. Now what we need to do is draw that asymptote from this center. Now, all we're going to do is we're going to look strictly at this number right here, 4/3. From this center, I'm going to do 4/3 as my slope. So I'm going to go up 4 over 3. Okay? Now that's going to be the asymptotes right there. So that first asymptote, okay, so then now from this point, you're once again going to do a negative 4/3. So that means down 4 over 3. If you wanted to do the rectangle thing again, you could. Then that'll work. You've still got your rectangle there. You can go ahead and draw it in. But don't get hung up with those parentheses. Just look at the slope. Because that's all you're doing.
So what's the point of even writing all of them? Why don't you just always do it?
Because the equation, or the problem said find the equations of the asymptotes. Yep, I gotta see that. So, draw on your hyperbola and you should be good to go. So questions about that, because that one was actually shifted a little bit.
I honestly thought that was easier than
So, you think you can handle that?
I think that's the easiest.
Okay. So, real quick, we're not going to do this today. We're actually going to continue with this on Monday. And what you can go ahead and do is you can go ahead and get started on your assignment. If you want to go ahead and turn in your book to section 3. So we are talking about page 449. So page 449.
And have you got your videos to work?
I'm getting them right now.
Oh, you are?
Okay, what I need you to do on 449 is I need you to do 2 through 8, the evens. And then I need you to do 12 through 18, the evens. Okay, now what we're going to end up doing is we're going to add some stuff to this tomorrow. Okay, plan is that you'll have a quiz over hyperbolas probably Monday. Okay, but